In our last class, we were discussing the microbit. We learned that it is a pocket-sized codable computer, and it has a number of features that we're going to be able to use in our classes. And I'll just quickly go over what some of those features were. It has 25 LEDs arranged in a 5x5 grid array. It has 2 buttons that we can use to program to actually get it to do other functions. It has a compass and an accelerometer that allows us to measure movement of the device. It also has the ability to have Bluetooth and a few other parts as well with it. But today we're actually going to discuss what we need to do to get started programming on the microbit. So we're going to actually think about what inputs are and how they're important and how we use them. We're going to think about what logic is and why that is important and how that's used. We're going to have a look at loops. We're also going to have a look at variables. And then later we're going to work on starting our scripts or our programs to run on the microbit. Let's move to what our inputs are. Our inputs, this is from our last topic when we did input processing output. Inputs allow us to enter data into the digital system. They're things like when we press a button, when it registers a shake, something like that. The processing is when the digital system processes the data and changes it into something new for us. And the output is when we actually look at what the data is. So we might put into the microbit to actually show something on the LED array. It will actually format it so that the writing that we actually put into it comes up one by one and scrolls across the screen, and then it's outputted on the digital array. So we are going to actually have a look at inputs. So inputs are really handy for us because we need to actually interact with the device. So there's a number of different inputs it has. One is when we press the button, and there's 2 different ways we can code the button pressing. And then there is on a gesture like a shake or a movement, and there's 2 different ways we can actually access that programming of that. There's also on other things that can happen, like a pin being pressed. There is a compass heading. There's just measuring the accelerometer. There's a temperature sensor in there as well. So these are all inputs that we can actually use in our program to actually make the microbit do some decision making for us. An example of using an input is the code below. When button A is pressed, the microbit is actually going to show the string hello. So it's waiting to see when the button A is pressed, and as soon as that happens, it's going to actually show the string hello. And so that way, nothing will happen in this particular case until after button A is pressed. So we're also going to talk about logic and what actually is logic. Logic's an interesting thing, and I've got a big definition there about how it's reasoning by humans in order to form thoughts and opinions. Some logic can be used by computers, and even animals use logic. Logic is a process for making a conclusion and a tool you can use. The foundation of logic is its argument or propositional statement. And this is either going to work out to be true or false. Now, if you remember our last topic, and we did a lot of things about binary, so it's going to be either accurate or it's going to be false. There's only 2 states. It's either going to be right or it's going to be wrong. It's going to be true, it's going to be false. And it all comes back down to this binary that we were learning before, that computers really only like to work in this, is it yes or no states. They don't like to have any grey area or something in between. So when we're doing computers, our logic has to be able to be determined as either true, and if it's not true, it's going to be false. An example of formal logic in this case is all spiders have 8 legs. Black widows are a type of spider. Because all spiders have 8 legs, we know now that black widows have 8 legs because it is part of the group of all spiders. So that is the way a logic decision is made. Okay, so we could actually say this to the computer: all spiders have 8 legs. Black widows are a type of spider. Black widows have 8 legs, and it's going to either return a true or a false answer. And in this case, it's going to return a true answer because black widows are a spider and they have 8 legs. Okay, so that's what logic's about. How do we use logic? We use logic by making these statements like this one. If something happens here, and it's going to evaluate as either true or false. And my example of that is going on from the flowchart that we created not so long ago was, if the traffic light is red or equals red, show the string stop. So basically, this is the case of, if the microbit works out that the traffic light is red, then it is going to actually show the word stop on the screen, showing that string. But to add to that, well, what happens if the light's not red? So we've got an extra extension we can add to this if statement. If the traffic light is red, it's still stop. But otherwise, we want to keep going. So if it's not red, because this happens if it's red, and this section here means otherwise. So this word else will means otherwise I want you to show the string keep going. So if the traffic light is red, it's going to say stop. If the traffic light is anything other than red, it's going to say keep going. This doesn't work really well for us because this was the same problem we had with our flowchart. What happens if the traffic light is amber? But we're not getting involved with that today. Okay, loops. Loops are also another part of programming that we use. And why are they important? Well, there's a couple of reasons why we can use loops. Is one, it can clean up our code because we can actually do things that we want to repeat a number of times. And instead of repeating the code a number of times in our program, we can actually just tell the program to repeat this piece of code a number of times. And in this case, it's saying repeat 4 times. And this example on the right here is showing me where I'm going to repeat 4 times, show the icon, the heart, then show nothing, all LEDs off, and then show the icon, the heart again. This is actually going to give me a little flashing heart program. So the heart will actually beat. Okay. So that is, and it'll do it 4 times, and then it will go on to if there's something else to do, or that will be it. So it'll beat 4 times. So instead of just doing 1 flash, because this is repeating 4 times, it will repeat 4 times. But the other thing that we can do with loops, we can apply our logic to it the same way we did with our if statements. So where this says true here, we could put our logic statement that says, if the traffic light is still red, right, or if the traffic light is red, show the flashing stop sign. And so the flashing stop sign will keep flashing, and then it'll keep checking the traffic light until it's no longer red, and this part won't be true, and then the loop will actually drop out and go and do something else. So that's basically ways that we can use loops. We can actually use them to actually repeat a number of times. We can actually use them to test for something and repeat until that test is, or repeat while the test is true, evaluates to being true. Okay, what is a variable and how can they be used? So the other thing that we were going to talk about was variable, and I snuck one in the traffic light one. In programming, a variable is a value that can change, and it depends on conditions or information passed to the program. One of the things that I like to say variables is like, it's like using memory on your calculator. You've got something on your calculator and you want to remember that number for later. you put it into memory so you can calculate something else, and then you can pick up that number and add it into the calculation. This is really helpful if the number is really long, because you don't have to write it down and you don't have to remember it, because the calculator will remember it for you. Later on, you'll change that memory and put a different number in the calculator's memory. So this is basically what a variable is. It's like a little memory location, but we give them our own names. In our case, I've given the name of the memory location traffic light. So here, I've added to my program from before. I've said set traffic light to red. And then if the traffic light is red or equals red, then it's going to say stop. Otherwise, it's going to keep going. So if the traffic light wasn't red, I could have said set traffic light to green. Then when it would read this, it would say green doesn't equal red, so it would not show this part, it would show this part. So this is one of the ways we can actually use variables, especially good if something in our program is going to be changing a lot. So we want to actually use a variable so we can actually load the value into the variable. We don't have to change it at every other point in the program. So that's using variables. Okay, what's next? Next, we're going to work on programming the microbit, and we're going to have a look at Microsoft MakeCode, which is what we're actually going to use to program the microbit.